So this one has a point slope. I know because that's its name. It's called point slope. The point is here and here, but you got to be careful. The 6 goes to the end, the 1 goes to the front, and then you got to be really careful with the signs. That's a positive 1, so you use a negative 1. That's a negative 6, so use a positive 6 right there. There you go, negative 1 comma 6. Raise your hand if you had that one right. Good, you've learned a really, really critical point there. Then the slope is 2. It's all it is that number, super easy. Now, can you take that same equation, I'm going to rewrite it, y minus 6 equals 2, parentheses x plus 1. Can you multiply it out and get one of the other forms? Super critical for your next test, super critical for algebra in general to be able to solve for y. It involves a little distributing, which is one of the basics, one of the basic 20. It involves some solving, which is one of the basic 20. All right, you should have said y minus 6 was 2x plus 2. And then the way my high school did it, and you can do this way or not, is you go over here and make it the opposite. Now, if you rather just add 6 to both sides, that works, then it'll cancel it out. But my high school, we just said, I moved it so it's not here anymore. Y equals 2x plus 8. Raise your hand if you had that one right. Okay, cool. I think you have a headphone. That's why you're not fully paying attention. Take headphones out. All right. So now I have this other form, which is called something. Slope. Say it. Slope what? Slope intercept. All right. Point slope, slope intercept. But then there's one more form where you put the x first. My high school's way, grab it, move it to the other side, and it would be negative 2x plus y. I just moved it over there and made it the opposite. And that's it. That's called standard form. Because the x is first, and then it's the y, and then it's another. Do you feel like you get those 3 forms? No. Then the only thing that's new for today is if I were going to graph something like you did graphed yesterday, like y equals 3x plus 1, I'm just going to take 2 seconds and go, where's the y-intercept? Say it if you know it. 1. There's the 1. And then I go rise 3 and run 1. And I put another dot there. Anything wrong with this graph? Do you feel like we got this? Do you feel like you can do that? Okay, because that's part of the test. Then the next step is, and this is the last new thing for today, other than this, we're just going to make sure everybody's got their basics down. As in, we're just going to practice things like this on a basic 20. And this time, last hour, we got 8 people that got a perfect paper on it. So you're going to try a paper basic 20 all on your own. The worst score was 9 out of 20. The best score was 20 out of 20, and there was a lot of them. So I'm hoping a lot of you are like, oh my gosh, you haven't got this down yet? Yeah, we still have to get these down. And algebra basics are huge, and I'm going to just keep on pounding on it until you've got it. So here's the only new thing. If I change this to less than or equal to, first of all, would you have known that was a less than sign? There's always a few kids that can't tell the signs apart. That kind of looks like it has an L in it. That's a less than sign. All right, so when you're going to graph this, it's going to be the exact same thing, except kids think of this wrong when they think of the left side of the graph and the right side of the graph. That is not what you should think. you should think below the graph or above the graph. And I know this one's so steep that it would be easier to think left than right, but that's going to mess you up. Below the graph or above the graph. Because this graph is a less than, you want to be less than it, which is below it. That means you just shade on one side of the line. That's it. So you graph the line, you shade on one side of the line. How do you decide which way to shade? Less than is like under. And that makes sense. If you're like, your height is less than the other kid, you're under them. You're below them. Okay? So less than shades below this line. The only line in the world that doesn't have a less than or a bigger than is a straight up and down line like that. And these are confusing. Let's say it's going through the number 8. Then that is the line x equals 8. That is the only kind of line where there isn't a below the line or above the line. It's impossible because it's vertical. And then you only have a left or a right. That's the only kind. But we're not going to try to shade on that side of a line. We're just going to be shading on lines that are more like this. And if I said, can you tell that I just shaded under the line? That's pretty easy, isn't it? So if it's a less than, you shade under it. If it's a greater than, you shade above it. Let's see if you've really got that. Ready? I'm only going to do like 2 more problems. Y minus 6 equals 2 parentheses x plus 1. I just gave you a point and a slope. And now I'm going to change it to a less than. Whoa. All right. First thing I want you to do is distribute this out. We're going to solve this thing for y. Because the only way this thing works is if it's solved for y. Y minus 6 less than or equal to 2x plus 2. Moving the 6 over to the other side. Oh yeah, I remember this one. Y less than or equal to 2x plus 8. Cool. Then you graph it. How'd you know how steep the length of the line? Well, the slope was 2, so I went up 2 and over 1. That's how I picked. And then Asen, which way should I shade? Yeah. It says less than, so I'm going to shade below it. That's it. They give you an equation. You have to be able to solve it for y, and then decide which way to shade on either side if it's an inequality. And if it looks like a less than, you're going to shade below it. All right. Okay, there's only one more little tiny tweak. What if it didn't say or equal to? I want to remind you of the difference here. If I said on the old school graphs that are on the basic 20, and you said that's greater than 6 or equal to 6, if it had been an empty circle, that's greater but not equal to 6. Do you get the difference there? That one it could equal 6, that one it cannot equal 6. Well, what if I change this and I say, I actually didn't mean to have it or equal to. It's just less than. Well, then the only difference is it can't be equal to the line itself. So I know that your line will just like erase if you do what I'm doing here, but I'm just going to put in a bunch of little empty spots. I think you guys have a dotted line maker. I've saw some kids have figured that out. So it's kind of like an asymptote. It's a dotted line. Why? Because it wasn't equal to. If it says or equal to, it would be a solid line, like it was. If it's just a less than or just a greater than, then it's a dotted line. All right, and there's usually a few kids who are my A students who like, I want to understand why this is like this. Let me explain why it is like this. Because this spot right here, for example, that right there on the line, that is the point 1 comma 10. That point right there is 1 comma 10. If I put 1 and 10 into the equation, it'll read 10 is less than 10. Is 10 really less than 10? No. So that point doesn't work. Things that are on the line would make it equal to. That's why it needs to be a dotted line, because things that are on the line won't work. They'll read something like 10 is less than 10, which is not a true statement. If it was or equal to, then it would be true, and that's why the point on the line would work if it was an or equal to. All right, so I just graphed this really quick, and it goes through -2, so this is y equals, looks like a slope of 1x, and then it's -2. You should be able to catch on to that super quick and go, that has a slope of 1, it goes through -2. You with me so far? What if I say, change it to greater than? If I go greater than, got a shade above it. As long as it's greater than or equal to. What if I made it just greater than? Dotted line. This one's greater or equal, so it's a solid line. Only thing that would be different is if I took away the or equals, then I'd have to make it a dotted line. Okay. There, you've learned the new thing for today. Now, in lieu of homework, we're going to do just 2 problems like this, okay? Once before we take the basic 20, and then once after the basic 20, to make sure that you remember the thing for today. So, can you graph this y is less than or equal to 3x minus 3? You should be able to find the y-intercept. You should be able to go, oh, the slope is this over this. Remember that it's a shaded or dotted line. Ooh, you better remember that. And then you gotta shade under or over your line. All right, you guys work on that for a second. This is the one problem we'll take before we take the basic 20. And maybe because we had that hold, maybe we don't have time to do a after the basic 20 question. Okay, now you start with a -3, you put a dot there, then you rise 3 and you run 1 and you'd be right there. How do I know that that's 3? Because I went down 3 to get there, so I go up 3 and over 1. Now I put a line through it. And now I shade, it looks like an L to me, so it's a less than. I shade this way. And is it a solid line or a dotted line? Since it's or equal to, it's a solid line. How many of you had that one right? Okay, good. So, that I hope felt really easy, because all it was is shading on one side of the line. You already knew how to graph lines from yesterday. All right. So I know, this is kind of easy. But we're finally getting to the point where we're pulling all the basics together from this basic 20. I want to remind you of a couple of the most common mistakes. Kids still don't know how to do this. I know because I asked last hour and I walked around and this is one of the questions that came up. I know some of you are like, come on, this is easy. All you got to do is take that and you change it into a times problem. So it's no longer a divide problem. It's 1/2 times what? 4 over 3. And now, you have to know how to do that kind. Well, you multiply across the top, multiply across the bottom, you got 4 over 6. And then it would be kind of tragic to have gotten that far and left it as 4 6, because I think you all know that that's like 2 times 2. That's like 2 times 3. The reason I do that is so I can cancel that and I see my answer's 2/3. See? I think that's the easy way to reduce. Some of you will just see it and go, oh yeah, it's 2/3. Cool, you can do that. You don't have to show your work on reducing. But I think changing it to multiplies, which is called factoring, it's my favorite thing. If you can factor it, you should, right there. and you factor it, and then things cancel. All right, here's another one. I think most people know by now that this is 2 times 10, and this is 2 times 5, and then you're like, okay, so I factored it, and those are primes. So this is called prime factoring. Do you remember that? But how do you write the answer? You don't just leave it like that. You sum it up by saying, so my prime factors are 2 times 2 times 5. If you want to be extra, you could say that that's 2 squared times 5. But guess what you get when you go 2 times 2 times 5? You get 20. That's the whole point. So you write your answer like that. Okay? All right. So there's one other one that is, I think, the toughest on the whole basics. 1/3 plus 2/8. Would everybody please think through what would be a good denominator? You can use a calculator. 24. You always just times them. Now please copy it to where I am so far. Then 8 has to turn into 24. You'd use a calculator. You go 8 times what makes it 24? 8 times 3. And if you times this one by 3, you times this one by 3. 2 times 3 is 6. And if you times this one by 8, you times this one by 8. And I get 8 times 1 is 8. And now at the end, some kids don't understand this. You just add the tops. The answer is in 24ths. So you can't add the 24s. That doesn't make any sense. If I had 1/3 plus 2/3, I would have 3/3. The bottom just stays the same, see? All right. So this one is in 24ths, and 6 plus 8 is 14. 14 24ths. Why is that wrong? Simplify. And the way I like to simplify, 7 times 2, 12 times 2. Cancels. If you have a faster way than me, cool, but there's not much faster than that. 7 12ths. Okay, so let's take that basic 20. Clear off your desk, have something to write with. This is just for the pride of it. You should want to be able to prove you've got Algebra 1 down. I'm not going to put this in the grade book and hurt your grade. Not right now, because it's a holiday for some kids and they're gone, and it wouldn't be fair to make them have to make this up. And so this is just to see if you've got this. We are going to take it one more time for real, where it does count, but that's not today. So let's see if, for some of you, when we put this into the homework, it's going to count as like 40 points of homework, which is like 4 homework assignments. So you really do want to know this stuff if it counts as 4 homework assignments. It doesn't now, but later it will. So moral of the story, if you can get this to be really a good score, it'll help your grade in my class. All right, not enough? Khalid, can you hand her yours? And then why don't you come up and... All right, so on your mark, get set, go. And some kids finished in 8 minutes. Don't feel like you have to.